Let's take the next one. Let alpha be a real number and the three vectors A vector, B vector, C vector are coplanar, right? The question is talking about that there are three vectors and S is a set such that these are coplanar. So you have to talk about set S. Let's check out if these three are coplanar, then what is the possible value for alpha. Coplanar meaning scalar triple product equals 0. So let's write down the coefficients. Alpha 1 3, then you have 2 1 minus alpha, and you have alpha minus 2 3 is equal to 0. Just simplify this determinant to get the result as alpha square plus 6 equals 0, meaning no real value of alpha is possible. When no real value of alpha is possible, so this set is actually an empty set. So the correct answer for this question is option number 4. Let's move on to the next one. The length of the perpendicular drawn from the point 2, 1, 4 to the plane containing the lines these two is. So first you need the equation of plane containing two lines, and how we write it? Simply x minus x1, y minus y1, z minus z1, a1 b1 c1, a2 b2 c2, the determinant equals 0, right? So let's start this question now. You can say the determinant x minus 1, y minus 1, z, because the point is 1, 1 in both. If it would have been different, even in that case you would have taken any of the two. Next, b1 is 1 2 minus 1 and b2 vector is minus 1 1 minus 2 is equal to 0. I'm sure this is clear. Now simplify this one to get the equation of plane, which is x minus y minus z is equal to 0. What is next required? Length of perpendicular dropped from the point 2, 1, 4. Therefore, perpendicular length is equal to, the point was 2, 1, 4. So it is 2 minus 1 minus 4 upon root 3. Take the modulus of it, so it is simply equal to root 3. Let's check from the options. Correct answer is option number 4. Let's move on to the next one, that is question number 18th. So taking up question number 18, let alpha between 0 to pi by 2 be fixed if the integral tan x plus tan alpha upon tan x minus tan alpha dx is equal to this one. You have to talk about ax and bx. Let's plan this question. If you say I is equal to integral, if you change it into sine and cos, you can clearly see this becomes sine x cos alpha plus cos x sine alpha in numerator and with negative sign in denominator. So it is sine x plus alpha upon sine x minus alpha dx. Here you can put x minus alpha as t, so that integral becomes sine x is t plus alpha. So you can write here sine t cos 2 alpha plus cos t sine 2 alpha, right? What I did, x equals t plus alpha, so we have sine t plus 2 alpha divided by sine t. Now when you distribute this denominator, you can see sine t is cancelled, you are left with cos 2 alpha multiplied with the dx only. Here we also have dt, right? So it is multiplied with dt. So just write down cos 2 alpha multiplied with t plus sine 2 alpha multiplied with log. You can check cos t by sine t, that gives you log sine t plus constant of integration. Now this is further can be written x minus alpha into cos 2 alpha plus sine 2 alpha into log sine x minus alpha plus constant of integration. Now when you compare with the given one, you can clearly see x minus alpha log sine x minus alpha is there. You can put modulus sign as required for this function. So after integration, it can be done. Now, just check one more thing. If you multiply this cos 2 alpha here, it is x cos 2 alpha minus alpha cos 2 alpha. This can be added to the constant of integration and can be written as x cos 2 alpha plus sine 2 alpha into log mod sine x minus alpha plus c1. Now, I can plan this time, let's say plus alpha cos 2 alpha, and here we can see from this c1 minus alpha cos 2 alpha, which will give you another constant of integration, meaning that x plus alpha into cos 2 alpha can also be considered. So from here, x plus alpha and log sine x minus alpha and mod can also be considered. That means option 2 can also be correct one. In first go, we are getting option 3, but when you check, because it is integration, constant of integration is already there, so it can also be considered as option number 2. So this was about question number 18. Let's move on to the next one.